So let's get started. So I'd like to start off with a chart. Some of you may, others of you may not know that global population right now sits about 7 billion people. By the time 2050 rolls around, we're going to be sitting around 10 billion people. And as you might conclude, we're going to need more people or more food to feed those 2 billion more people. Now, to make that a little bit worse or a little bit harder to figure out how much we need, we got to consider the fact that as countries get richer, they eat more and more meat. For example, it takes 9 calories of plant-based chicken food to make 1 calorie worth of chicken that we eat. You talk about a bigger animal like beef, and the inputs are even higher with 25 calories of plant-based food to 1 calorie of beef. Meaning that not only do we have to account for the amount of plants that we need to grow for us to consume, but we also need to factor in the fact that the amount of livestock that we're going to need to consume is going to need to go up, and we're going to have to feed those livestock. Not to mention, farmland peaked in somewhere in the 1990s. We're not making any more farmland right now. In fact, it's decreasing year over year as we continue to urbanize. So many of the things that we enjoy, the developments we live in, the apartment complexes that we might live in, the roads that we drive on, the shopping malls we visit, the data centers that house all of our data, a lot of those things are coming out of what was formerly farmland, meaning that we've got less farmland than ever, and that trend is expected to continue. So the obvious conclusion, right, is that we're going to need to feed the world on less acres of land. Meanwhile, we've got an average farmer that's 58 years old. He or she works 12 to 18-hour days, and finding skilled labor is getting harder and harder. Some of the reasons behind that, we're seeing a rural to urban migration as kids leave small farming communities, coming to cities looking for better opportunities, new jobs, etc. You've got an aging industry demographic. What do we mean here? Most of the people that are farmers are getting older, and most of their kids aren't wanting to take over the farm. You're seeing less and less young people involved in farming. Not to mention, in the US, we don't have tropical climates, right? We grow pretty much from the spring through the fall, and then we shut down in the winter. That seasonality doesn't really make it easy for most people to sustain their lifestyle, making it a little bit harder. Bottom line is, we've got about 2.4 million jobs that we need to fill on farms today. So the obvious conclusion, right? We need to find a way to hire more farmers and farmhands. I'd say that's a hard sell. You've got long hours, hard work. I'm sure everybody can relate to that. Comparatively low wages compared to some of the other sectors that are out there, and those seasonal impacts that I already talked about. In my opinion, what we really need is automation that allows us to scale the amount of human operators we have by letting machines work autonomously so those human operators can focus on the activities that they really need to focus on as humans. And a final challenge that I want to cover today is climate change and sustainability. This is something that we've been doing for a long time, right? We spray for weeds and pests to make sure that they aren't going to eat our food before we get the opportunity to or stunt its growth, right? We fertilize and amend our soil to make sure that it is fertile and is going to produce the most amount of food possible. There's still room for a lot of optimization in this space. Really what I'd want to focus on is plant monitoring of the health in the field and using large data sets in order to do predictive analytics and get ahead of the trends of what might be going on in your field based on what you're predicting. So this is where I'm going to take a little bit of a Deere spin, right? There's going to be more opportunities that I'm going to go through later, but really what I want to focus in here is how Deere is tackling some of these since it's what I'm most intimately familiar with. Growing more crops on less land, first thing I want to highlight is our operations center. You can think of this as the command center for the farm. Basically, it gives the farmer the ability to see where all of their machines are at in the field and do command and control operations for planting, harvesting, etc. But what we're doing is we're actually collecting a lot more data than that. As those machines are going through the field, they're collecting all sorts of data on the field, moisture levels, soil samples, etc. We're also combining that with weather data, with chemical and fertilizer supplier data, and potentially data from trusted advisors, whether they work at a university like Penn State or elsewhere, allowing us to bring all of that data together for the farmer and give them a whole up picture for what's going on in their field. We believe that more data means better outcomes for the farm. Next one up, I'm going to show you what I think is a pretty cool video about technology we call See and Spray. Let's see. Is this coming up or no? Working on two things here. All right. So check this out. So just a quick 10-second clip. I'm going to explain it in a little more detail here. So what you just saw is one of our latest technologies called See and Spray. Basically, it's a twist on a traditional sprayer using a lot of really cool technology. So the boom that you see there is 120 feet long. It's carbon fiber. Has to be because it needs to be light enough to go through a field without causing soil compaction, yet rigid enough to be able to hold our cameras. We got 36 cameras going across that boom, along with 10 vision processing units with custom NVIDIA chips that have been ruggedized for the farm. Pretty cool product that we've got there. So what's going on here is we're using computer vision, machine learning to identify plants in a field. It can determine what is a healthy crop, for example, corn or soybeans, and what is a weed. And within the blink of an eye, it can tell you what kind of weed that is, about how big it is, and how much pesticide is going to be needed to sprayed to kill that weed. And it will spray that all within that blink of an eye, which is really, really cool. What the so what is here is this is real. We're using it today, and it's resulting in a 60+% reduction in the amount of pesticides that we have to spray. That's 60% less pesticide that our farmers need to buy, which is a huge input cost for any farmer, and that is 60% less pesticide that's ending up on the food that you and I all eat. So a big deal in reducing the amount of pesticide that makes it into our food chain. That said, it's not the silver bullet. It's not getting to zero, right? It's one step in that direction. It's going to continue to get better over time, but we still need some help. So number one, pesticides with less health effects. I think that's more prevalent than ever, given some of the things that we see coming out with Bayer recently. Or potentially some non-chemical ways to address weeds, right? If we don't need to spray a chemical, if we could mechanically pull them, engineered dirt that won't allow for them, do something crazy like that, there's probably some opportunity there. Not to mention, we probably need some fertilizers that don't come from fossil fuels, because if you didn't know it, most of our fertilizers currently do. Next up, this is probably going to be the longest of the Deere sections. This is on autonomy. This is our force multiplier, and this is probably an area where I'd say the big guys have it covered, but I'll let you be the judge. So what you're seeing here is an 8 series tractor, second to the largest series that we build. You might notice, if you can see, there is no operator in that tractor. And these are out in the field right now, and in fact, they tilled and planted this spring using these with some of our largest farmers. So how do we do that? We've got a Starfire GPS. Think of this as like the GPS chip in your phone, but with sub 1 inch accuracy, meaning as you're going down the field, it is going to line up exactly with where you want to plant or spray or do whatever with that row. Now, knowing where you are on Earth is one thing. Knowing where you are exactly or what's in front of you is another thing. We've got multiple stereo cameras all around this vehicle, providing constant input of what is exactly around that tractor, giving the virtual operator the opportunity to stop itself in the event that it sees some sort of abnormality. Finally, we also have LiDAR in there. We believe that LiDAR is a core component to being able to see what's in front of you. We're not doing this all with computer vision, which is a little bit different than if any of y'all have seen what Tesla's doing, right? They're obviously going all computer vision. We think a hybrid approach is best. Finally, we do have the ability to do cellular connectivity where it's available. However, where it's not, we recently inked a deal with Starlink to be able to connect our machines in the field no matter where you are in the world, which is pretty cool. Again, software-wise, a lot of CVML and self-driving algorithms here and a bunch of embedded software, which is where my work is. But the result we've got here is that we've got a tractor that runs on its own in the field and is getting ever more smart. Got another video here. This one's on Gus. This is a joint venture John Deere has. And I guess we're watching an ad, unfortunately. Thanks, Google, for nerfing my ad blocker. And that's not the link that I set out to click. What the heck? There it is. All right. So these are pretty cool. These are orchard sprayers. You're going to see them go down the field and blast. I believe these are almond trees for this video. Basically, they're going to be able to go down these rows of trees autonomously and spray the pesticide, in this case an insecticide, on those almond trees to keep the bugs from eating the almonds so we can enjoy the delicious nuts that come off of these trees. They're pretty cool. Again, this is a joint venture we have and something we're really excited about for growers in California, where most of the U.S.'s nut production actually goes on. It probably has some other applications for other types of orchards and maybe even vineyards, but something really cool that we're putting out into the market with a partner, a little bit different than most of the in-house stuff where we typically either integrate a startup or integrate a startup's technology alongside our own in order to put together a really cool product. And then, as you might expect, we're the big green tractor company. If you've figured out how to take one of those gust sprayers and make it work autonomously within a couple rows of trees, we can do it with a tractor as well. We put this out at the Consumer Electronics Show this January. They're going to be shipping this year, but basically, yes, this is an autonomous 5 Series tractor designed for orchard and orchard use. All right, now on to sustainability and decarbonization. It's a long road ahead, and I'll explain why. So number one, you might be thinking, well, why doesn't Deere just go and electrify everything? Number one, today's batteries aren't energy dense enough for us to be able to work those 12 to 16-hour days that farmers put in and year out. And these machines are way too expensive to expect a farmer to buy 2 to 3 of them in order to get the job done in one day. So that's not going to work. On top of that, we've got weight impacts. Now, you might know that the heavier a car is, the more impact it's going to have on the street. It's got the same effect on the dirt, except for it results in soil compaction, which is something that farmers are really keen on making sure does not happen. On top of that, we have investigated some biofuel type stuff. We're finding that there's some basic economic challenges there to get it to be as cost efficient as diesel, as well as some growing challenges on how we might be able to grow crops for fuel on top of meeting that growing food demand that we have coming up in the next 25 years. So solutions we still need. If you can crack the code on making lighter, more energy dense batteries, please bring that to us. Everyone probably would love that. And if you can find a way to crack the nut that is sustainable and economically viable, biofuels, again, probably a grown winner right there. That said, we're not counting out electricity, we're doing it where it makes sense. So that 5 Series tractor is about as big as we can go right now with our current battery tech. We bought this company out of Austria called Kreisel Batteries. They've got an immersion cooled battery that we're using in this tractor, and it is promising to have that 12 to 16 hour battery life that is demanded by the farmers in an electric form factor. This is again for those orchards and potentially some livestock type operations, smaller tractors. You got to remember we go up to the 9 Series tractor, right? So this is kind of right there in the middle. Those bigger tractors right now are not commercially viable in an electric format. So we're working on it. And what I found out is that, just like now, it took me about 30 minutes to deliver that, and there's some more opportunities I can tell you about because I've got an hour. So, food waste. Did you know that 1/3 of the world's food, about 1.3 billion tons a year, goes to waste? So any way that you could find a way to disrupt that food somewhere in the supply chain and prevent it from going to waste, whether that is repackaging it as something else that could be stored on a shelf in a refrigerator long term, or redirected from the United States or another country where there's a lot of food waste to a country that is starving for food, you've got a winner there. Or if you believe that some of this food waste is inevitable, I mean, how many of us have committed to eating healthier? We buy that big package of lettuce at Wegmans, we eat through half of it, and we've still got those 2 heads of kind of suspect lettuce in the back of the fridge. I know, me, right? Yeah. So if you can find a way to repurpose that in a way that can make you money, you might be onto something. I was thinking, potentially if you could run a composting service for somebody, they might give you what they paid for free because it's already rotten in the back of their fridge. Potentially. Now, for some of you, maybe you're inheriting the farm, or maybe you think the farm is the option. My advice to you is to be craft beer, not Coors Light. By the way, if you are buying a farm, sound place to stash your money. Farmland does tend to beat inflation, so good place to hold on to large sums of money. What do I mean by this, though? Coors Light is a commodity beer. It's brewed in several places across the United States. It's the exact same everywhere you get it. Nothing wrong with it. It's a great beer to have when you're at a baseball game or a football game. But that said, it's not the only gig in town, and there are other differentiated styles. So what I'm saying is if you're going to run a small farm, you want to try and be differentiated, whether that means going organic, whether that means being extremely local in your marketing, saying I'm the local farmer you can trust, whether that means pairing up with craft brewers, craft distillers, someone who's going to use your end product and putting your farm's name on it so people can get that idea for where the product actually came from. Or potentially growing some types of ingredients that maybe aren't as mass market, right? Typically, your large farms grow a lot of mass market soybeans, yellow dent corn. There are other varieties of corn. There are other varieties of soybean. There's other crops that you can grow. So if that's an option for you, go ahead and look at some of those other crops and see if maybe you can deliver on those. Or maybe you want to pull a Samba share and go to Africa. So fun fact, half of the population growth we're going to see in the next 25 years is going to be in sub-Saharan Africa. Now, that's pretty cool, but farms in that area of the world are half as productive as in other countries. Now, it's not all their fault. Some of that is growing conditions not being ideal, which is the case many places in the world. But likely they're going to be remaining reliant on foreign imports for a long time. But if you can help improve mechanization in sub-Saharan Africa, irrigation, fertilization, pest control, infrastructure, all the things that are necessary for a thriving ag ecosystem, you have the potential to make a boatload of money. Or maybe ag's not your thing. Maybe you're more into construction and road building. As I mentioned earlier, one of the biggest problems we have when we go into developing countries as John Deere is we find that the farmers can grow the food. The issue is getting their roads, their bridges, their ports, and their cellular connectivity up to snuff so they can take advantage of some of the latest innovations we have and basically get their food to where it needs to go. Another cool thing I've been seeing a lot about, perennial crops, regenerative agriculture. Some of you might be familiar. What we're seeing right now is that they're not nearly as productive as their annual counterparts. Kernza, probably the best marketed of the bunch, is about 1/3 as productive as your regular wheat. What does that mean is that it's not really economically viable to go ahead and produce tons of Kernza in replacement for wheat. Even if you could, right, you also still have a marketing question as to how do we market this food as a viable alternative that people are going to love. People go out and they buy flour. What's going to make them want to buy Kernza flour when they don't necessarily know what it is? Even some of these brands, you know, Cascadian Farms, Patagonia Provisions, right? Those are big brands. I guarantee you that only a couple people here have heard of these Kernza grains that are going into these things or would actually buy them. It's quite a good beer if you can find it, though. Another cool thing about Kernza, though, those roots. So they grow deep. So not only do you get to harvest from this plant multiple times in its lifetime, but it sequesters a heck of a lot more carbon into the ground by growing it as compared to your typical grains, as you can see there on the left. Potential to be another carbon type offset. And finally, I want to talk about biofuels and SAF. As I mentioned, we're seeing some economic challenges here. The good news is the airlines can't get enough of the stuff. They're all committed to decarbonizing. They know that fuels are a major part of their carbon footprint. We can't grow enough of the stuff. Camelina and other oil seeds are the main way that we do that. And what we found is that cropland is more economically productive, growing soybeans, corn, other types of things. We're looking at intercropping as well as some ways to increase the yields of those camelina plants to get more output per acre. Word's still out on whether we're going to be able to do that with the current generation of technology and what's going to need to happen there. But if you can find a way to advance some of this biofuel type stuff, the airlines will certainly buy it. Deere's looking at it for potential biofuel drop-ins for existing diesel engines. Heavy machinery manufacturers as well are looking for it. So wrapping up, wanted to quickly mention Deere Startup Collaborator. Some of you may have heard of it. Some of you may not have. The point here is that your technology might have an ag application. So if you look down the list here, LandScan's probably the only one that is a pure agriculture play, doing digital twins for your growing fields. Array Labs does 3D satellite imagery, definitely has an ag vertical, but certainly isn't the only one. LiDAR has a lot more uses in other places than it does in ag, though it does have a place on the farm. AI on machine safety probably should be going in every self-driving vehicle that we come up with, right? Resim, software testing. If you have any software engineers in the house, you know that testing is very, very important. And anything that we can do to automate that, orchestrate that, make it better is definitely a winner. And Witricity, wireless charging for vehicles, probably has more to do with your car than with ag, yet we see an ag application. So the point is here, if you're working on something, consider ag as a potential vertical, because you might have the opportunity to place your technology into the agriculture space where you might have thought it's more of an automotive or more of an aerospace and defense type of concept. Finally, that Hello Tractor company that I talked about at the beginning, they're pretty cool. So they started out trying to be the Uber or the Airbnb of tractors. So in Africa, a lot of times the farmer is not actually the owner of the tractor. In fact, you've got a tractor operator who services multiple farms. So they set out to turn that into an app where you can go ahead and set up your time with your tractor operator. He'll come plow your field, plant your field, do whatever. And that was great. But what they found when they were scaling their business was actually that most tractor operators did not have the opportunity to get a bank loan to buy a new tractor. In fact, only 2% of banks actually finance tractors in the developing world. So what does this mean? That means that, number one, Hello Tractor's business model was set to kind of hit a max, right? It couldn't scale without this financing. So they went and pivoted to a financial services company, and they started underwriting pay-as-you-go financing for their proven operators to help entrepreneurs within Africa go ahead and scale their businesses and go from their first tractor up to maybe their 10th or 20th. Not only did this go ahead and increase equity for those entrepreneurs and give them access to capital that they desperately needed to be successful, and they are successful, but it's increasing mechanization in sub-Saharan Africa where they desperately need it. So super, super cool company. John Deere is a minority investor in Hello Tractor, and I was super excited to see that a Penn State company was going out there to meet with them. And finally, last bit on John Deere, to be clear, we're not just ag, right? We work in construction, we work in road building, and we work on turf care equipment as well. A lot of the solutions that I showed you today show up in other ways in these solutions, trying to make our customers more green, more sustainable, and more profitable as they continue to go. That's really our guiding star at Deere, is how do we help our customers achieve those things. So I'm happy to talk about anything having to do with any of these spaces. I know ag the best, but we definitely have some cool stuff going on here as well. And with that, I'll open it up to questions. What do we got?
Have you ever considered like a multi-layer farm?
Multi-layer farm?
Yeah. I'm saying how there's like an aquaponic farm where it's just multi-layer where like the bottom benefits from like the waste from the top. So maybe something similar to that and can benefit from like limited land.
Probably something worth exploring. I haven't seen much research on it, to be fair. Most of the stuff that I consume comes in through John Deere, so I get a kind of a agricultural machinery slant, right? So it sounds like an interesting idea. I've seen the aquaponics type stuff, or where you've got your fish growing obviously in the water, and then maybe you've got some solar stacked on top of that, and maybe a wind turbine as well, combining your sustainable fishing alongside some sustainable energy production. But I haven't really considered much of that myself, no.
Question. So a lot of this technology is very up and coming, and it seems like it's for bigger farms. How are you dealing with smaller family-owned farms that really don't want to implement some of that new technology?
And
is that a challenge you guys see?
It is a huge challenge. It's one of those things where, by nature of it, it's almost alienating some of our customers in some ways. And we're coming around to different ways to price this, right? So, charging $1 million for a sprayer is probably not feasible for the family farm. And what we've typically relied on is over time, the big farm will buy the latest and greatest. And over the course of the next 20 years, it'll make its way into the family farm's hands. So we've explored some new pricing models where you kind of pay as you go for the use of the equipment, and not necessarily paying the $1.5 million up front in order to get there. We're still working out what all that looks like. Some people are a fan, some people really love it, some people are like, another subscription, you gotta be kidding me. But we're starting to see more and more people come around as they see the finances actually work out. Because when you look at it from a business perspective versus your personal, I'm tired of paying $26 a month for the premium Netflix subscription, I'm there, right? But when you look at it, okay, maybe I don't need to take out as much capital in the beginning of the year in order to finance my whole operation. Instead, I can just pay out of these cash flows. There's ways to make that balance sheet work for the farm, for sure. So, yeah.
What about for construction equipment? How does that technology kind of differ from the farm?
A lot of it's the same, right? So we use some of the same Starfire receivers, the stereo cameras and whatnot. We've really focused on grading automation, right? So it's pretty hard to go ahead and sustain a really tight grade as you're trying to level out a piece of land for a construction project. So that's been our biggest opportunity is, using technology, and our GPS, keeping that grade completely flat as we want it, as we're trying to level out a job site. That's been the biggest thing. We've also jumped into some electrification because construction equipment, especially excavators, don't need to move nearly as much as, say, a tractor through a field. So it was a lot easier for us to electrify, which is basically a stationary digging arm that has to move every once in a while to reposition versus some of the other things.
Can you talk more about the Starfire GPS technology and how it actually works, the detection and all that?
So I don't have all of the details here, but we do have our own constellation of satellites up in low Earth or orbit. And basically, it works similar to other GPS technology. I know what really makes it work or gets us to that sub-inch accuracy is a bunch of terrestrial stuff going on with the equipment and type of correction algorithms we have on board, but I can't speak to that directly. I don't work on the Starfire team. Any more questions? What's up?
When it comes to your field in agriculture and like how that intertwines with like software engineering and like more leaning towards like AI and stuff like that, how would you want to see AI operations more so integrated within your field?
Yeah, so we're using a lot of, I'm assuming you're talking about generative AI. So we're using a lot of that today more on the input side. So as an assistant to a software developer within the company, lending a hand with developing code or acting as a pair partner type of deal. What we're not seeing is a real strong use case to just drop ChatGPT into a tractor, right? There's probably some applications I could see where somebody has a question about their machine, they're having a problem, being able to have an intelligent agent go out and fetch relevant service documentation or provide troubleshooting tips, something of that nature. But as far as the customer-facing side, I don't see generative AI taking over in this space quite as much. I would think of it as a potential productivity booster, giving us the ability to churn out more code, develop more features more quickly, but I don't see it as the killer in this space.
What other regions are expected to have big population increases in the next 25 years?
I mean, the rest you're going to see it kind of across the board. Sub-Saharan Africa is about half. You're going to see some in South America. Asia's probably hitting its peak, right? We've been seeing India on the rise for a long time. China's obviously had a huge population, and I think we're starting to start to see peaks in Europe and in Asia, and then obviously in the United States, we're probably going to see some population decline eventually as well, people having less children. That said, the overall global number is going to continue to go up despite some of these places seeing a little bit of decline. Oh, we'll keep it on questions. I didn't mean to click my button.
What other technologies do you use when mapping out fields?
Field mapping? So the most basic, the way we start is actually we'll take a John Deere Gator with a Starfire GPS, and we'll first boundary map the entire field. So we'll go ahead and we'll run the edge of the field, and that basically sets our containment area. So that's a hard fence, a hard boundary that we're not going to go over. And then if you think about it, as we go through the production cycle, we're going to go ahead and plow a field, right? And then we're going to go ahead and we're going to start planting seeds. And those seeds are going to remain pretty much in the exact same place we left them. So as we're going through the field, we are calculating location data the entire way as we plant. Then that map can be exported to the cloud and then put on a combine later in the year. So let's say we just planted however many rows of corn. We then, come harvest time, go ahead and download that map and drop that into a combine. And that combine will follow that exact same path through the field as when we first started planting, allowing us to basically not miss a single head of corn. Same thing with spraying, right? If we can stay on the exact same path that we used to plant the actual crops, our spraying can be a lot more accurate as well. So a lot of stuff going on there.
How does John Deere compare to your competitors with all the technology that you're doing here?
Yeah, so I'd say I know for a fact we're out investing our competitors right now. That said, the competitors are definitely fierce. They're, Case is putting out similar technologies as well. I'd say they come at different price points, and they're probably for different scales of farms or different needs or sometimes different philosophies about how this equipment gets into the hands of the farmers. I've heard some people compare us to Apple and them more to Android, right? So just a little bit of comparison there. I don't fully endorse that as a way of thinking, but the competition's definitely fierce. And then when you look overseas, you've got Klaas from Germany, a big player there. And then when you look at our small ag equipment, Kubota is obviously huge. You see them out here all the time. I think Penn State as a Kubota house, right? So you definitely see them around as well. So definitely a lot of fierce competition, and we're definitely investing for the future to make sure that we stay ahead of those competitors. Anything more, y'all? Well, hey, if anyone has any questions they don't want to answer on air, feel free to stop me. I'll probably be around here for a little bit more. Again, my name's Ryan Ostir. I work at John Deere. It was really a pleasure talking with all of y'all today, and I hope you guys have a great startup week. Thank you.